Hey everyone, welcome to Code Harmony. Today we are going to solve Leetcode problem number 2257, count unguarded cells in a grid. In this problem, we will be given a grid of size m cross n and the two arrays which are giving us the position of guards and walls. If you have a look on this example, here this is the grid. This G is indicating guard position and W is indicating a wall. And what they are saying is that a guard can see the position in the 4 direction like this, and starting from their position unless obstructed by a wall or another guard, and the cell is guarded if there is at least one guard that can see it. Okay, this is what the problem statement is saying, that from guard we can go to every direction, right, down, up, left, until we are encountered with the wall or another guard. We will keep on guarding all the cells between this path unless obstructed. And what we have to return from this problem, return the number of unoccupied cells that are not guarded. So all the remaining cell we have to return the count of all the remaining cells. So here in this problem statement, all of these red marked cells are guarded by any of the guard, and these cells which are marked green, these are unguarded, and we have to return the number of those cells, 3, 4, 5, 6, 7. So 7 is the answer for this grid. So this is our problem statement, and now let's see how we are going to approach this problem. First of all, we need to know that our grid is going to have some kind of valid cells or invalid cells, or you can say guarded or unguarded cells. Initially, I can assume that all the cells are unguarded. If all the cells are not guarded, let's try to keep it 0. Here, I can either have a valid cell or invalid cell. Apart from these, there are two special positions. One is guard location, second one is wall location. So valid cell is something, let's say whenever I'm having 0 in the grid, I will call it valid. And for invalid or guarded cell, and this is the guard position, wall position, let's try to keep it something like, for every guarded cell I will try to keep it 1. For every guard position, let's keep it 2. For every wall position, let's keep it 3. And what we have to do is, we need to start making cells guarded from every guard. Let's say whenever we are encountering a guard position, let's say at index ij, I am getting a guard. So from this guard, I can go in all the 4 directions and keep on making these cells invalid. I will call these cells valid and invalid for all the unguarded cells and guarded cells. Let's go to the right, then left, top, down. So from all of these directions we will go, and I will keep on going. Let's say in this direction I am having 0th row, which means that a valid cell. I will make it invalid. I will say that I have guarded this row, and after guarding this row, guarding this cell, I will move to the right direction, and I will not move in any other direction. So I will keep on moving in that specific direction. And if the up cell, let's say it is 0, I will make it 1, and I will keep on moving in this direction. I will keep on guarding cells in this direction, So when we are going right, I will keep on going right. When I'm going up, I will keep on going up. In this way, what I'm trying to say is that I will keep maintaining the direction. So let's say in the up direction, I need to pass a direction variable, so that I will get to know that from which direction my previous call is coming. Let's call it a up direction, let's call it down direction, right, left. So these are the 4 directions, right, left and up, down. Okay, So this is also clear to us that we have to go 4 direction, and whenever we are encountering any wall or let's say any guard I'm getting, I will just discard this call, or I'm going out of bound, I will just discard in that case as well. And here I need to make all the cells invalid which are not allowed for us. So I will start making cells invalid or guarded from each guard location. It means that I need to start moving in these direction, or you can say I will start my DFS from every guard location. So first of all I need to capture all the guard location, and guard location is given to us in this array. From this array, from every location, I will start making my DFS along with the direction that start making cells invalid. So initially these are the guard location 1, 2 and 3, and the guard location I am mentioning as 2. So all of these 2 are the guard location, and along with that wall, this should be clear that this is the only valid cell and all of these are invalid. Whether the cell is guarded or the guard is present there or it is a wall, all of these cells are invalid for us. We just need to have the count of this valid cell. So all of these guards I have already marked, and I will try to mark all the walls. Now in this grid I have marked guard and the grid. Now I can start my DFS, and DFS is going to start from every guard. So let's start making DFS call from the first guard. From the first guard I will go in all the 4 direction: up, down, right, left. Up call is discarded because it is going out of bound. Right call will be discarded because we are encountering wall. Left bottom call or down call is a valid call. In this case I will keep on making the cells invalid, and I am passing direction along with the call, and this is the left direction. Left direction is also out of bound, so I will cross it, and I will keep going in this direction. I will making this call invalid, moving further invalid, and then moving further invalidate. So I will keep on invalidating these rows, and all the invalid or guarded rows I am keeping 1 as a flag. So the first guard's work is done, and now I will come to the second guard. Second guard I can go to the 4 direction: up, right, left, down. Up call is discarded. Right call will keep on going till this guard. So let's see the right call. After the right call it will look like this, and after the bottom call it will look like this, and all the left call it is 1. Again we will just keep on setting 1. So this is the state after the work of second guard is done. Now we'll come to the third guard. Third guard will make these rows invalid. All the rows in the column we will go, and when we are going up, this is already 1, keep it 1, and this is already 1, this is 0, I will make it 1, and in the right I will make all of these 1. In the bottom make this 1. When we are coming left we are encountering 3, so we will not do anything. So here if you have a look that we have done our DFS calls from every guard. Initially there were 3 guards, so we will make a loop, or we will start 3 DFS calls, and in every DFS call we will try to maintain the direction up, down or right, left, and along with this direction we will keep on going until we are encountering a wall or a guard. And now in the end just directly capture the number of zeros in the grid. Zeros are all the valid cells. And how many zeros we are here? 1, 2, 3, 4, 5, 6, 7. So 7 is going to be my answer of this. And what is going to be my pseudocode? First of all, fill all the grid with 0, or you can say directly initialize the grid. Second one is mark all the grid with a valid value, because in the input statement I am only given the coordinates of the guards and walls, so I need to fill my grid with some values. Here I'm keeping these value as the annotation to mark the position of every single type of entity. So for the valid cell, initially all the cells are valid, mark it with 0, and invalid or guarded cell we will keep on capturing during our DFS calls. And walls, guards will be marked as 2, walls will be marked as 3. So okay, the filling is done. And then for every guard, starting DFS in all the 4 directions: up, down, right, left. When we are moving up, I'm also passing a flag that I'm going in the up direction. Here I will be passing that I'm going in the right direction, and so on, the down direction and the left direction. When we are moving up, the value of row will be decremented, I-1, and when we are going down, the value of row will be incremented. When we are moving to the right, value of column will be incremented, value of column will be decremented. So these are the 4 DFS calls. And all of these 4 DFS calls, if we are found any valid cell, it means if I found a cell with the value 0, I will make it 1. And if I am on the border, or I am getting a guard, another guard and another wall, I will just discard the call. So this is going to be my terminating case. Otherwise I will keep on doing the DFS. Now let's have a look what is the time complexity in this problem. Time complexity is that we are initiating calls from every guard location. So number of total DFS call initiated in the starting, in the first go, will be the number of guards. Let's say the number of guards is G. And in every guard, we are invalidating number of cells. And how many cells maximum, how we can invalidate? We can invalidate at max M cross N, because it is a grid. So G into M into N is going to be the time complexity in this case. What is the space complexity? I'm taking this extra grid for my calculation or storing the result. That is going to be order of M cross N. So this is the time and space complexity of this approach. And here, as I'm making calls invalidate, so the maximum times any DFS call can go till M cross N. Let's start writing the code for this problem, where nothing special is required apart from vanilla recursion. And here, firstly, I need to set the values in my grid, because we are given guards positions and wall position. And let me take my grid globally so that I don't need to pass it in my solution function. This grid is going to be of dimension M cross N. Let me take this M cross N as well, global as well. Int M, int. This grid by default is going to have 0 in it, so all the cells are valid in the starting, and these guards and walls are not valid, so I will just invalidate these 2 positions in the starting. For every guard, I need to make it invalid. Grid guard 0, guard 1. This should be this we decided as 2. And same thing for the walls. Wall, for every walls, grid wall 0 and wall 1. All the walls are going to have 3. And now I have 0 in the grid, 2 in the grid, and 3 in the grid. Now I need to set 1 for all the guarded cell. And it means that I need to start my DFS for every guard. Where is every guard? I need to do this guard for each loop again. Let's capture ij in the starting. Guard 0 is the ith index. Guard 1 is the jth index. I need to make DFS call in each direction. How many directions I am having? 4 direction: up, down, right, left. And when we are going in the up direction, it means row will be decremented by 1, and In the down direction, row will be incremented by 1. Right direction, column is increasing, and in the left direction, the column is going to be decreased. Okay, these 4 directions are fine. And after these directions, in the DFS function, I'm going to invalidate these valid cells. So once any valid cell is guarded, I will just make it 1. And after this, after all of these DFS calls, I'm going to have only 0 which are not guarded. So I need to iterate over this grid. I equal to 0, I less than. For every row in every column, if the grid value is still 0, I will increment my answer, and in the end I can return the answer value. I also need to initialize it to 0. Okay, my base function is ready, and now I just have to implement this DFS function. The DFS function is going to require the initial index and the direction and these many values. So that's why I wrote these globally. So here I'm going to have 3 main things: negative edge case, guard this position, move ahead. And we are when I'm guarding this position, what I'm doing is, for every grid at this value ij, I'm setting 1. And my negative edge case, if I'm handling the negative edge case, it means I will be definitely sure that when I'm coming to this position, I will only be having 1 in that current 0 at that current position, and I will need to mark that guarded. What is negative edge case? When we are crossing the boundary, when we are encountering a guard, encountering a wall. In this case, we just have to return from the call. The call is not going to add any value. If it is going out of bound, row and column, any value is less than 0 or getting equal to the size, number of rows, number of column, or the guard position is it is a guard position, or if it is a wall position, in that case I just have to return from my DFS. Nothing is required. Otherwise we have to move ahead in the same direction. So if I am coming from up direction, I will keep going in the up direction. If it is left direction, I'm coming from the right direction. If I'm moving in the right direction, just keep moving in the right direction. So I need to check the condition here. If let's say direction is equal to up. If the direction is up, what I have to do is I need to do the DFS in the up direction. When we are going to up direction, how my indices are going to be changed? In the up direction, row value is decreased. 1, 2, 3, up. Now down. When I'm going down, row value is getting increased, and I'm going in the right direction. Then I will remain same, and j will be incremented. When it is left direction, then I will remain same, and j will be decremented. Okay, a very simple DFS function. Negative case, then return directly. If it is not a negative case, a valid value, the guard this position. Otherwise move ahead. Up, down. If it is down, it should also be down. Up, up, down, down. ठीक है. And this is the left. Now let's have a quick look on our implementation. This is my grid, and I'm an MRN. And for every guard, I'm marking it 2, and for every wall, I'm marking it 3. And then from every guard, I'm initiating a DFS call with the proper direction: up, down, right, left. And in the end, I will be left with only unguarded cell as 0. Now in the DFS function, negative case, and okay, let's try to submit over. Let me run over sample test cases. It should be grid. There was a typo. Now sample test cases are passed. I'm submitting the problem. The time complexity is number of guards into number of cells. Okay, it is submitted successfully. Hope you have understood the problem. Thank you guys. Bye bye.